Hey everybody, it's Mr. N here, and we've got the next section. This is on differentiation formulas. So basically what this is I'm going to teach you guys now the shortcut to how to take derivatives. First of all, let's take a look at this. The derivative of a constant, is 0. Okay, well, why is that? Well, that's just the concept of having a horizontal tangent, right? So if we've got a constant value, and I'll just draw a quick grid right here. It doesn't matter where the value is, whether it's up here or over here, down here. It doesn't matter where that constant value is, right? The slope of this tangent is horizontal, so that's going to be a slope of 0. So the derivative of any constant is 0. Again, that's like graphing y equals 5. Or y equals -2, or even y equals 0, right? Any of those derivatives, the derivative of a constant will be 0. Okay, so now we've got these power functions. So basically like a polynomial. So x to the second power, x to the third power. And you can even have fractional powers. It works with fractional powers. This is the power function. If n is 1, then derivative with respect to x is 1. If n is 2, x squared becomes 2x. So let me give you examples. If I have y equals 5x, the derivative of this is just y prime would be equal to 5. Okay? So if I had, I'll put a second example over here, y equals 3x plus 2. Y prime would be the derivative of this, which would be 3, and then that goes to 0, so y prime would just be 3. So here's basically what you're doing. If you have x to a power, you're taking this, and you have a constant in front, you're going to multiply it by that, and you're going to then subtract 1. So the derivative y prime would be a times, this is y prime, times the n, okay, then x to the n minus 1 power. That's how you would do it, and you would do it for every part of it. You would do it for this one, for this one. So that's what a quick formula would be, and I'll talk about that down here when we get to the formula. So if I had y equals 2x, this derivative, so suppose you had this y equals 2x, y prime would be 2. Now I'm writing it as y prime, and I could just say derivative with respect to x of this x squared would be 2x. I could write it like that as well. Over here, notice that it's to the third power, so the derivative, y prime, would be 3 times x to the second power. So here is the pattern that I had talked about above, and we're going to write it here as this power rule. And you're going to take whatever constant you have in front, and this is not written as a constant, it's just to the n times whatever you have in front, and then you're going to subtract and bring it down a power. So let's do it to these examples right here. So over here, find the derivative. F prime of x would be 5x to the fourth. So this goes out in front, you multiply it by whatever it is, and then you subtract 1 from the power. F prime of x would be 200x to the 199, and so on. And now here's where I was talking about before. If you have a constant out in front, you're just going to multiply it by that constant. So nothing changes there. So over here, we have the derivative with respect to x of 5 times x squared. This gets multiplied by the constant out front, so I'll get 10x to the first power. Okay, then the next one, the derivative with respect to x of negative 2x to the fourth. When I take this derivative, I multiply that 4 by the negative 2, I'll get negative 8. X, and then I bring this down a power by subtracting 1 to the third. So that's how we do these two problems. So again, it's going to be the constant times your power, then you have the x, and then you're going to subtract n minus 1. So subtract 1 from the power. Now, it doesn't matter if you've got multiple things going on. In fact, here's another example. 2 times 15 gives you the 30, and bring that down 1. It'll be x. So, as I always say, here's some rule. Get what I did there? You see what I did there? Here's some rule. No, it's the sum rule. So if you... yeah, I just cracked myself up. Okay, come on. You got to enjoy the dad jokes there. So if you've got f and g, and you've got differentiable functions on each, then you can just say the derivative of f plus the derivative of g. So this basically lets us do if we've got multiple terms. So we just take the derivative first, then the derivative of the other one, and so on. So derivative of f plus derivative of g plus derivative of h. So in other words, now if I set up a polynomial such as y equals, let's do f of x, because I've been using y up above. So let's write this as f of x this time. F of x equals 3x to the fourth plus 2x to the third minus 5x squared plus, I don't know, 10x minus 12. Okay? Taking this derivative with the sum rule lets me do the following. This times this, 12x subtract 1 plus, now I do the next one, 6x squared. Over here, negative 10, let's fix that, negative 10x to the first power, plus 10, right? 1 minus 1 is 0, so x to the 0 is just 1, so it goes away. And then the derivative here of a constant is nothing, so I don't put it. It's derivative of constant 0. The derivative of a constant equals 0. I can't tell you guys how many times I see the mistake that you'll put minus 12. No. The derivative of a constant is 0. This is a constant. There's no x's on it. X to the 0 power. 0 times whatever number you put out in front is 0. Done. It's gone. So this is how you would do it if you've got a big polynomial with multiple terms. And again, it doesn't matter if the powers are fractional, so it doesn't have to quite be a polynomial. All right? And we're just applying sum rule. See what I did there? Sum rule. Sum rule. Okay. All right, I think I beat that one. I gave you that example right over here where I had a negative. All right, now moving on. Let's take a look at what we got now. Of course, we're going to have the difference rule, but, okay, so it doesn't matter if you've got a negative here, you can do the same exact thing. So over here, you can combine the sum and difference rules. So here's another example. I took the derivative. 4 times 6 is 24, x to the third. 3 times 2, 6, x squared. 2 times 5, 10, x, and then 1 times negative 7 is negative 7, and the derivative of constant is 0. So now, look at, now we've learned how to take the derivative using the shortcut. What does all this mean? This means the limit as h goes to 0 of f of a plus h minus f of a all over h. That's what this derivative is, right? This is the definition of a derivative. And now I've shown you a shortcut by using the power rule. So it makes all these derivatives, all of this, so much easier. So now take a look. We could do this tangent line question super easy. So we have to find the slope of the tangent for y equals 3x squared plus 2x minus 4 at x equals 3. So here's what we do. What is the slope of the tangent? The slope of the tangent is the derivative, right? Which is this limit as h goes to 0, all that. But we don't need to do that. We just do the shortcut. Y prime becomes 6x plus 2. Where do I want this happening? At 3. So y prime of 3 is going to be 6 times 3 plus 2, which gives me 18 plus 2 is 20, and that's the slope. There you go. So the slope is 20. We can move on to these particle position question. We could find the velocity and the acceleration. So here's how we're going to do these. To find the velocity, velocity is the derivative of the position, right? We talked about that. So now I could just take the derivative of this and I'll get the velocity function, and that's just going to be 3 times 2 is 6t squared. 2 times 4 minus 8t plus 6. That's a constant. It goes away. There you go. Now I can find, since that's my velocity function, if I take the derivative of velocity, I'll get the acceleration function. And now I could take the derivative again, which is the second derivative of the position. And I'll get 12t minus 8. So there's all of part A. For part B, it asks for the acceleration at 3, so now I just need A of 3, which becomes 12 times 3 minus 8, and this is going to be 36 minus 8, which is 24. And that's, there's no units on that, so we'll say units per second squared. And that becomes that simple. That's how easy it becomes when we use the shortcut. Now let's take a look at what we got here. Now we've got this thing called the product rule. Well, we know what we do if we're adding f of x and g of x and h of x. We just do one at a time, which is what I had talked about over here. Just like on this one, you just take the derivative of this one, then the next one, then the next one, then the next one. But what if you have something that you're multiplying? What if you're multiplying two functions? Well, then that becomes the product rule. So if f and g are both differentiable, then the derivative over here using the product rule, so f of x times g of x would be the first times the derivative of the second plus the second function times the derivative of the first. Your author shows you why this is true. Stewart shows it on page 139, so you can take a look at there, and I'm not going to go through all the steps on that. But it's not a distributable thing. You're not saying f times g. Notice how it's not just f prime times g prime. You're not doing that. You have a whole rule that you have to follow. You have to take the first function times the derivative of the second plus the second times the derivative of the first. Now people ask me, can I do the derivative over here, the second times the derivative of the first, or the derivative of the first times the second plus then the first times the derivative of the second? Yeah, it's the same thing. It's just flip-flopping this. But typically, this is how we memorize it, as the first times the derivative of the second plus the second times the derivative of the first. So, but I'll show you a little bit differently also, because you can have more than one, and I'll talk about that in a sec. So here it is in function notation this way. The big function f of x, and if it has these two that you're multiplying, the derivative of this would be the first times the derivative of the second plus now the second times this derivative of the first. Okay? Now, the next question, the logical question that a lot of students always ask me is, what if you have 3? What if you have f times g times h, and you're going to do the product rule for this? You can have as many as you want, but you have to do it. Basically, you're taking the derivative of each one. So that's really what you're doing with this. And I can break this down to you. It's not a formula like, it is the same formula like this, but we don't memorize it like that anymore. So basically what you're doing, and you can apply it to this one too. You certainly don't have to memorize it this way. But that's how we typically do it. But over here, getting back to this, you just have to basically take this derivative times these two functions. Plus now you do the next one. This derivative times these two functions. And now you do the last one. This derivative times these two functions. So you're just going from one to the next. So as long as you have the derivative of each one times the other two, you're set. So you can do this for as many products as you want. So which leads us to the next one, which is the quotient rule. And I have a typo, big typo here in my notes. This should be minus right there. So let's talk about this. If you are dividing two, what you do is you take this bottom one times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Again, Stewart proves this for you guys so you could see how it works on page 141. I'm not going to go over the proof, but let's take a look at it in a little more here, and I will break it down like this, and it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So our function like this, f of x over g of x, f prime becomes the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And now, it doesn't matter if you have negative powers or fractional powers. I've told you, as I've mentioned with fractional, you're just subtracting 1 each time, and you're multiplying this. So even if it's negative, you multiply the negative. You subtract 1. So let's do these two examples. So for this one, we're looking at it, and we've got f prime of x equals, well, it's negative, so that's okay. I just multiply it by here, so I'll get negative 10. X, now look, what do you have when you get negative 5 and you subtract 1? You're going to get negative 6. So remember, it goes down 1 power. It goes down. So if it's negative, it's going to go bigger negative. All right, over here, f prime of x. Okay, well, I have a negative out in front. That's okay. Negative 3 times negative 2 becomes positive 6, x to the negative 3. Plus, all right, let's see here, negative 5 times 1 becomes negative 5, x to the negative 6. Yes, you can rewrite this if you want to say x to the negative 3 minus 5, x to the negative 6. That's okay too. All right, now what if you have 1 over n? Well, if you have 1 over n, then we're just going to use the same rules. There's no need to do a product rule or a quotient rule here. There's no, don't do that. We have no business doing that for this. What you can do is you just change this to be x to the negative 2. Right? You know how to switch powers up and down. So now when you take the derivative, you're going to get negative 2 x to the negative 3. Okay, so then I get the next question. Do I need to change this back, just like I didn't do it over here? Do I need to change this back and write it like this? Look, if you're doing a homework problem, leave it like that. If you're doing a multiple choice part of the test, they will probably present the answer in this manner. They won't present it like over here. You'll have 6 over x cubed minus 5 over x to the 6. That's how they'll probably present it on a multiple choice test. All right, so now moving on to this, we are going to rewrite this. And look at how I'm going to rewrite this. I'm going to say 3 over 2. I'm going to keep it fractional like that, right? And this x becomes a negative 5. So 3 over 2, x to the negative 5. So now I take the derivative, f prime of x. Negative 5 times 3 halves, right? I'll write it all out. X to the negative 5 minus 1. So this becomes negative 15 halves x to the negative 6. That's the derivative. So here's a summary of everything we've done so far. Starting with the one you forget the most, and I'm telling you this just out of reality. The derivative of a constant is 0. That's it. It's 0. Here is the power rule. Here is what you do if you have a constant out in front. It just stays there. Here is sum rule. Remember, sum rule. Here is the difference rule. This is the product rule. And this is the quotient rule. Okay, so that's a summary of all the ones we went over. So now let's do some examples. We are going to find the derivative of each of these. So this is a good spot in the video for you guys to get some practice, where I would really suggest going ahead and hitting that pause button, doing these, and then coming to check your answers. So for the first one, y prime becomes negative 2x. That's it. Derivative of a constant is 0, people. Okay, for the second one, y prime. Now, this is 1/3 x cubed minus x, right? That's how we can see this. So this becomes 3 times a third goes away. So I get x squared minus 1. Over here, I would need to use the quotient rule. So for this one, we're going to say y prime equals the bottom times the derivative of the top, which is 3, minus the top, 3x, plus 5, minus the top, times their bottom, which is just 3 again, over this bottom squared. Okay, so now I'm just going to clean up the top here, and I will get, cleaning all this up, you can say 9x minus 6 minus 9x, and this will be minus 15 again. So on the top you'll get negative 21, on the bottom you'll have this 3x minus 2 squared. You don't need to FOIL it out, so y prime equals that. On number 4, there's something called a chain rule, which I haven't taught you yet, and that's what you're going to need to use for number 4, but you still can do it a different way. This is how you need to rewrite number 4, like this. You've got the top and you've got the bottom in this manner, right? Because when I take this and put it on the bottom, the negative 1 goes away. So now y prime becomes the bottom times the derivative of the top, which is negative 1, minus the top, 1 minus x, times the derivative of the bottom, which is 2x, all over this bottom squared. I'm not going to FOIL it out on the bottom, just leave it alone. But we can simplify the top, so let's just go ahead and do that. This becomes negative 1 minus x squared. This becomes negative 2x plus 2x cubed, all over this 1 plus x squared, quantity squared. And now just cleaning this up a little bit here, and I just realized I made a boo-boo. That should be squared right there. So this ends up being x squared right there minus 2x minus 1 all over 1 plus x squared squared. All right. And moving on to this last one. Over here, we've got f prime of x becoming, and we're going to go ahead and use the quotient rule again. Interesting, I didn't give you an example with the product rule. They were all quotient rules, but that's okay. We'll do those in class. So over here, we've got the bottom times derivative of the top. That would be 2x. Bottom times the derivative of the top minus the top times the derivative of the bottom, which would be negative 3x squared, all over this bottom. 1 minus x cubed squared. Let's clean up the top. And I'm going to get here 2x minus 2x to the 4th. This will be minus, it'll be plus actually 3x to the 4th all over this squared. Okay? Which would give me this, and this would be x to the 4th plus 2x over 1 minus x cubed squared. All right. Well, hopefully you understood all these shortcuts, and this should make your homework easier now when taking the derivatives. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.